Today, we're going to take a look at solving rational equations that are presented in two different ways. The first way that we're going to look at is two rational values added or subtracted equal to another value. And the second way we're going to look at is something that's written as a proportion. So one fraction equal to another fraction. So in this first method, we're going to apply what we did in Unit 8 when we were adding rationals, where we had to have the same denominator on each one, and that denominator carries over to our answer. And then in our numerators, let's say we have A and B, you add your numerators to get that final sum. So looking at this first one, nothing needs to be factored. I have an 8 and an x and an 8 times x. So you could think of these as two separate factors. And it looks like I need everything to have an 8 and x. So I'm going to multiply this one by an x, this one by an 8. And now all three denominators have an 8x. So I now have x over 8x plus 16 over 8x equals 17 over 8x. So I know now that my denominators are the same, that x plus 16 has to equal this 17, because we set up here a plus b equals a plus b. The numerators are the same. So at this point, we can kind of ignore our denominator as we solve the numerator. So we have x plus 16 equals 17. And then when I solve for x, I find out that x equals 1. So once you have that common denominator, you can ignore the denominator and solve our numerator. Now, if I go back up there and plug in a 1 for x to check our solution, I have 1 over 8 plus 2 over 1 equals 17 over 8 times 1. So I have 1/8 plus 2 over 1 equals 17/8. Okay, if we convert that 2 over 1 to have the same denominator, multiply by 8 on top and bottom, I have 1/8 plus 16/8 equals 17/8. Whoops. So we have common denominator. I can do 1 plus 16 is 17/8. And that value did check out. Okay, looking at number 2, I see that this denominator over here can be factored as 2 times x minus 3. So it looks like that 2's and x minus 3's are the only factors that we have in our denominator. So this denominator is missing a 2. We're going to multiply top and bottom by 2. This one's missing x minus 3. And then that last one has both factors. So I'm going to go ahead and distribute where necessary. So this first one is 2x. This next one is x squared minus 3x. These are both over 2 times x minus 3. And then that equals 6x over 2 times x minus 3. So now that we have common denominators all the way across, we can take just our numerators and solve for x. So I have 2x plus x squared minus 3x equals 6x. So I'm going to go ahead and get everything to the same side. The 2x and the negative 3x can combine. So x squared minus x equals 6x. And then I can subtract, the 6x from both sides. So I get x squared minus 7x equals 0. And I'm going to choose to use factoring to solve. So I can factor out an x, and I'm left with x minus 7. And then we set each of these factors equal to 0. So x equals 0 and x minus 7 equals 0. This one is already solved. When I add the 7, I get x equals 7. So I have two answers, x equals 0 and x equals 7, that I need to check. I'm going to go ahead and check the 0 first. So I have 0 over 0 minus 3 plus 0 over 2 equals 6 times 0 over 2 times 0 minus 6. Okay, so I want to first off make sure that none of my denominators make a 0. So this is going to be 0 over negative 3 plus 0 over 2 equals 0 over negative 6. Because if any of my denominators made a 0, then it would be undefined and we wouldn't have that value wouldn't work. Okay, all of these don't have a common denominator. However, it doesn't matter what the denominator is. These are all zeros. So 0 plus 0 does equal 0. So this value works. And then plugging in a 7, I have 7 over 7 minus 3 plus 7 over 2 equals 6 times 7 over 2 times 7 minus 6. So as you can see, I've typed both sides of the equation into Desmos with that 7 substituted in for the x, and we get 5.25 on both sides of the equation. So in addition to 0, 7 is also a solution. So we can write it in our brackets, 0 and 7 as our solutions. On this next example, we need to go ahead and factor this denominator. So I have x minus 2 times x plus 1. And I see that each of those factors is on a separate fraction on the other side of the equation. So I'm going to go ahead and multiply this one by x plus 1 on top and on bottom, and multiply the other one by x minus 2 on top and bottom. So both the numerator and denominator have to be multiplied by that same factor in order to keep it an equivalent statement. So I'm going to go ahead and distribute this 14. So I have 14x plus 14, and that's over x plus 1 times x minus 2. And then I have minus, I'm going to distribute the 18. I have 18x minus 36 over x plus 1 times x minus 2. And then the other side of the equation stays the same because I already had both of those factors in my denominator. Okay, I'm going to go ahead and combine my like terms. I have this minus sign here though, so I need to change the sign on both of these things. So I have 14x minus 18x is negative 4x. And then I have 14 plus 36 is plus 50, and that's equal to 22. Okay, I'm not going to bring down my denominators. I'm only going to be working with the numerator because all of our denominators are the same. So remember, once we have a common denominator, we can ignore it and work with our numerator only to solve for x. Okay, so I'm going to go ahead and subtract 50 from both sides. Negative 4x equals negative 28. When I divide by negative 4, I get x equals 7. Okay, so I'm going to need to plug that in for my x value. So I have 14 over 7 minus 2 minus 18 over 7 plus 1 equals 22 over 7 squared minus 7 minus 2. So I've gone ahead and typed both of those into Desmos, the left and the right side of the equation, and we see that they are both equal to 0.55. So we have an equivalent statement. Therefore, x equals 7 is a solution. So we can write that in our curvy brackets. Number 4, I'm going to start by factoring this difference of squares. So x plus 1, x minus 1, and multiply to find a common denominator. So this needs x minus 1 over x minus 1, and this last one needs x plus 1 over x plus 1. So my first fraction is fine, 4 over x minus 1, x plus 1. This next one I'm going to have to distribute using FOIL or whatever you want to use. We end up getting x squared minus 2x plus 1 over x minus 1, x plus 1. And that's going to be equal to, we've got to distribute again, because remember, these are also in parentheses. So you get x squared plus 8x plus 7, and then over x minus 1, x plus 1. So now that all of our denominators match, we're only worried about the numerator. Okay, remember we have this minus sign, so we're going to change the sign of everything on this fraction. So I have negative x squared plus 2x, and then I have 4 minus 1, which is plus 3, equals x squared minus 8x, not minus, plus 8x plus 7. So I'm going to go ahead and move everything to the same side. I'm going to subtract x squared, subtract 8x, and subtract 7 to get rid of these things over here. Whoops, subtract 7. So all of these items zero out. I'm left with negative 2x squared minus 6x minus 4 equals 0. So now that I have a quadratic, I've got a couple of options to solve it. I'm going to go ahead and try to factor it. So in solving this, I see that we can factor out a negative 2 as a common factor. So I have x squared plus 3x plus 2 equals 0. And we can technically divide by this negative 2 before we factor. It's just going to make it a little bit prettier to work with, because anything when we divide by 0, or 0 divided by anything is 0. So I still have x squared plus 3x plus 2 over here. And then I can factor this as x plus 2, x plus 1 equals 0. So when we set each of our factors equal to 0, we find out that x equals negative 2 is a possible solution, and x equals negative 1 is a possible solution. So I want to go and plug both of those back into this original equation up here to see if we get true statements. So you can see here I've plugged in the negative 1 to the left side of the equation, and I get an undefined value. That's because when I plug in a negative 1, you can see that second fraction has a value of 0 in the denominator. So right here, we've got a 0 in our denominator. Therefore, the negative 1 is not going to work when we plug it in, because that's going to give us an undefined value. Okay, I'm going to go ahead and change all my negative 1s to negative 2s, because that's the other option that we had as a solution. So by changing these all to negative 2s, I do get a value. So I'm going to go ahead and plug into the right side a negative 2 to see if we get that same value. So I have negative 2 plus 7 over negative 2 minus 1. You see that you do get that negative 1.66666 repeating. So the value of negative 2 does work on both sides of our equation. So we said x does not work because that caused one of our fractions to be undefined, but negative 2 does work. So this particular problem only has one solution. Let's take a look at some of our proportions. So I said there were going to be two types of problems that we solve, something that's added or subtracted, and then some that are set up as proportions. So proportions have one fraction exactly equal to another fraction. When we have proportions, we're just going to cross multiply and set them equal to one another. So I'm going to multiply that diagonal 2 times a plus 11, and then I'm going to multiply the opposite diagonal 5 times a plus 12, and these two things are going to be equal to one another. So when I distribute, I get 2a plus 22 equals 5a plus 60. I'm going to go ahead and get both of the a's to the right and my constant to the left. So once I subtract that, I get negative 38. Oops, negative 38 equals 3a, and divide by 3. We find out that a equals negative 38 over 3. So I've already typed that into Desmos, and you can see that the left side and the right side are equivalent at negative 0.33333. So negative 38 thirds is a solution.
All right, let's do one last example, number 7. I'm going to go ahead and factor this denominator, x minus 5, x plus 2. So that means that this one needs an x plus 2, this one needs an x minus 5. So when I distribute, I get x squared plus 2x. Here I'm distributing a 3 and there's a plus sign between. So plus 3x minus 15 equals 7x. So they would all have the same denominator of x minus 5x plus 2. So I can just work with my numerators. So I'm going to combine those two things together. X squared plus 5x minus 15 equals 7x. Subtract the 7x. We get x squared minus 2x minus 15 equals 0. So that will factor as x minus 5, x plus 3. When we set each of those equal to 0, we find out that x could potentially equal 5 and or negative 3. So we want to plug those two values in for x. So as you can see, when I type in 5 for all of my x's, the left side is undefined because that denominator of the first fraction ends up being a 0. So we know that 5 will not work. Let's go ahead and try negative 3 for our x. You can see here when I plug in a negative 3 for all of my x's, the left and the right both give us equivalent values. So x equals 5 is not a solution, but x equals negative 3 is. So this one had one extraneous solution and one real solution.